How do planes fly? The miracle of flight is a marvel of modern engineering and physics, and understanding how planes fly requires delving into the principles that govern their operation. At its core, the ability of an aircraft to fly hinges on four fundamental forces: lift, weight, thrust, and drag. Each of these forces plays a critical role in ensuring that a plane can take off, stay in the air, maneuver, and land safely. Lift. Lift is the force that allows an airplane to rise off the ground and stay in the air. It is generated by the airplane's wings, which are designed with a special shape known as an airfoil. When air flows over and under the wings, it travels faster over the curved top surface than the flatter bottom surface. According to Bernoulli's principle, the faster moving air above the wing creates a region of lower pressure, while the slower moving air below the wing remains at higher pressure. This pressure difference creates an upward force known as lift. The angle at which the wing meets the oncoming air, called the angle of attack, also influences the amount of lift generated. Weight. Weight is the force exerted by gravity, pulling the airplane towards the earth. It is countered by the lift generated by the wings. The weight of the airplane includes everything from the structure of the plane itself to the fuel, passengers, and cargo. Engineers must carefully design airplanes to balance lift and weight so that the plane can ascend, cruise at a stable altitude, and descend safely. Thrust. Thrust is the force that propels the airplane forward, overcoming drag and allowing it to achieve and maintain the speed necessary for lift to occur. Thrust is typically generated by jet engines or propellers. Jet engines work by expelling exhaust gases at high speeds, producing a forward push based on Newton's third law of motion. For every action, there is an equal and opposite reaction. Propellers, on the other hand, work by spinning blades that push air backward, creating a forward thrust. Drag. Drag is the force that opposes an airplane's motion through the air. It is created by the friction of the air against the plane's surfaces and the turbulence caused by its shape. Engineers design aircraft to minimize drag through streamlined shapes and smooth surfaces. However, some drag is unavoidable, and it increases with the square of the plane's speed. There are two main types of drag: parasitic drag, which is caused by the shape of the airplane and its components, and induced drag, which is a byproduct of lift. The interplay of forces. For an airplane to fly, these four forces must be balanced. During takeoff, thrust must exceed drag, and lift must exceed weight to allow the plane to rise into the air. Once airborne, the pilot adjusts the thrust and angle of attack to maintain a steady altitude, where lift equals weight and thrust equals drag. During landing, the pilot reduces thrust, allowing drag and weight to slow the plane down and bring it safely to the ground. Control surfaces and stability. To maneuver and control the aircraft, pilots use various control surfaces. These include ailerons, elevators, and rudders. Ailerons, located on the wings, control roll and allow the plane to turn. Elevators, found on the tail, control pitch, enabling the plane to climb or descend. The rudder, also on the tail, controls yaw, helping the plane to change direction left or right. Together, these control surfaces allow the pilot to navigate the plane through three-dimensional space. Advanced aerodynamics and modern innovations. Modern advancements in aerodynamics and materials science have further refined the principles of flight. Innovations such as winglets, which reduce drag by mitigating wingtip vortices, and composite materials, which reduce weight while maintaining strength, have improved fuel efficiency and performance. Additionally, sophisticated computer systems and fly-by-wire technology have enhanced the safety and precision of modern aircraft. In conclusion, the ability of planes to fly is a complex interplay of physics and engineering. Understanding the forces of lift, weight, thrust, and drag, along with the control mechanisms that pilots use, reveals the intricate balance required to achieve and sustain flight. Through continuous innovation and a deep understanding of aerodynamics, aviation continues to push the boundaries of what is possible, enabling us to traverse great distances with speed and safety.